we will look at the concept of uniform circular motion as the next part of kinematics. Uniform circular motion. Yeah, Dhruv, in the end, I will come to the doubts. Okay, I will give some time for the doubts. But since some of the questions are also based on circular motion, let's understand. So, definition of uniform circular motion क्या होता है? So, uniform circular motion is the motion of a body or particle in a circular path at uniform speed. And further, what is a circular path? You know that circular path is a path in a two-dimensional plane such that the distance from a fixed point, which is called the center of the circle. This particular fixed point is called the center of the circular path, remains constant. So this is the definition of a circular path. Whereas this is the definition of uniform circular motion. Sometimes we just refer to it as UCM. So the definition of uniform circular motion. So just write this down. Then we'll understand more about the properties of uniform circular motion. Okay, so next thing we'll see that at any point of time or to describe the circular motion, what we do is we define the two-dimensional plane in which the motion is happening. That is taken as our XY plane. And the center of the circular path is taken as the origin. And then the path can be described by this kind of a shape, which is, as you know, in geometry we call this shape a circle. For example, the path could be like this. And this is the radius of the circle. So generally speaking, we take the plane of the circular path is the XY plane, and the center is at the origin. So then you can say that any point P having coordinates XY in the circle, such that its distance from the origin is fixed. So if the radius of the circle is r, so in meters for the SI unit, then the relation becomes that the distance to P should remain constant. In other words, you know that coordinate geometry wise, square root of x square plus y square will be equal to r, or we can say that x square plus y square is equal to r square. So this is what we call the equation of the circular path. So what we mean by equation of the circular path means that all points on the circle satisfy this equation. So that is what we mean by the equation of the circle. Yeah, this is the derivation of the equation of the circular path. Yes, you have to make a note of it directly. More importantly, you have to understand the equations while making a note of it. If there is any confusion with any of the equations, how they've come, please drop me a message. I will explain again. X and Y are coordinates. Okay. X and Y are called coordinates of the point. So I'm sure you are aware of the concept of coordinates of a point. Okay. And you are also aware of distance formula. Here we are making use of distance formula. In coordinate geometry, if you have two arbitrary points on the xy plane, let's say. You have one point, let's say E, which is x1, y1, and another point B, let's say x2, y2. Then the distance between these 2 points is given by a certain formula, which I'm sure all of you are aware of. The formula बताया ना आपको, the distance between 2 points, how to calculate. I'll come back to the last time, better, don't worry, Arav. But first of all, you know the distance formula in coordinate geometry. Alright, so you'll be learning it very soon in your mathematics coordinate geometry part. Given by x1 minus x2 whole square plus y1 minus y2 whole square. This is what is called officially the coordinate geometry distance formula. Okay. So here you can see that it's that formula only which is used. But one of the points is the origin, okay, and the other point is the point P. So you are applying the distance formula, the distance OP. That will be equal to how much? That will be square root of x minus 0 whole square plus y minus 0 whole square. So this is a formula from coordinate geometry in maths, which you will be learning very soon. Very basic formula. I think many of you might be aware of it also. But I should think most of you are aware of this formula. So when we say x square plus y square is equal to r square, where r is the radius of the circle, this is called the equation of the circular path. So what is the meaning of equation of the circular path? It means ये circular path में जितने भी points हैं, any points which are lying on that circle, they satisfy this particular equation. So that means the sum of their x coordinate squared plus the y coordinate squared is equal to this constant, which is r square. So that is called equation of circle in coordinate geometry, and this is called the distance formula. This distance formula comes from coordinate geometry in maths. I'm sure if you haven't studied it yet, you will be studying very soon in maths. Okay, write down the formula, you will study it very soon. Yes, Adina, that is correct. The distance formula is indirectly calculated from, yeah, you are aware of it, yes. So distance formula is indirectly calculated by applying Pythagoras theorem. That is in fact correct. Okay. So the distance formula actually comes by an application of Pythagoras theorem. But I will not get into that here. That you will be studying it coordinate geometry. So just note down the formula, that is enough. Okay. So using this formula, we get the equation of the circular path. Okay. That means, what do we mean by equation of the circular path? When the particles are going, when a particle is going along this circular route or it's following this circular path, every point on that circle satisfies this equation. So ये satisfies this equation का मतलब क्या है कि if some point is lying on this circle, its x coordinate squared plus its y coordinate squared must give us the value of the radius of the circle square. So that is the meaning of this. So for example, you can like this, that if a particle is moving on a circle of radius 5 meters, okay, in the xy plane, the center of the circle being the origin, okay, then find its y coordinate at an instant when its x coordinate equals plus 3 meters. So at an instant when the x coordinate is plus 3 meters, how much is the y coordinate? So just try to find this out using the above formula that we discussed. The formula of the circular path or the equation of the circular path is this one. So apply that over here and you will understand what we mean by equation of the circular path. Okay, Vyom and Aparna correct, but there is one more answer. You have given one answer, but there is one more answer. Center of the circle being the origin code. That is what is written in the bracket. The center of the circle is, yes, correct. Aparna, that's correct. So both the possibilities are there. There are two possible answers for this which you have now heard. Yes, Adinath, that's correct. Okay. So basically, what we know here is that we'll apply the concept that the radius r is equal to 5 meters. Okay. Therefore, equation of the circular path ये कितना हो जाएगा? This will become x square plus y square is equal to r square, or x square plus y square is equal to 20. Okay. Now we'll bring in this particular specific thing. So when x is equal to 3, you have to find the value of y. So substitute that over. It's 3 square plus y square is equal to 5 square, or 9 plus y square is equal to 25. Okay. Which means that y square minus 16 is equal to 0, which means that y minus 4 into y plus 4 is equal to 0. That means that y can be 4 or y can be minus 4. So that's why I said that there are two answers to this. So basically, you'll also understand this geometrically or visually how this is happening is that, let us say we draw a circle of radius 5 centimeters or 5 meters, whatever. Suppose this is our circle in the xy plane, the center being the origin, and this has a radius of 5 meters. Okay. Now x equal to 3 is somewhere here. So this is x equal to 3 meters. So now, where on this circle is x equal to 3? There are these 2 points on the circle where x is equal to 3. So our particular circular path, you can say it intersects this with at 2 points. There are 2 particular points where this happens. So one of those points is this one. This will be -4. So 3 comma -4 maybe ho sakta hai sir. And of course the other point is this one. 3 comma 4. So how we got the y coordinates? By using this. Okay, so hope the solution of this is fully clear. How to use the equation of the circular path to find out this. Okay, people. So this is clear, I hope. Okay. Now the next property of circular motion that we'll understand, and more specifically uniform circular motion. So we saw earlier that uniform circular motion that is motion along a circle at uniform speed at a uniform speed. Okay. So this, because it is happening at a uniform speed, this is a periodic motion. In other words, it's periodic means that it occurs in cycles, okay, or you can say repetitions with a fixed time period. So that's easy to understand why that happens, because what is happening is if a particle is moving along a circle at a constant speed. Now let's say the particle starts from this position here. Suppose here it starts at t equal to 0 from here with a uniform speed u. Okay. So it starts, then it goes like this, and let's say the radius of the circular path is r. The radius of the circular path is r. So you see that if it's going with the speed u, okay, you see that the particle completes a full circle in time 2 pi r divided by u. And every time it completes the full circle, what happens is that after this, the cycle repeats. The cycle of motion repeats. So that's why we say that it is a periodic motion. Okay. And not only it's a periodic motion, but we have a formula for the time period, with time period equal to the circumference divided by the speed. So further, how we are getting the formula of the time period? Because the time period is getting defined here as the time taken to complete one cycle. So the time taken to complete one cycle one cycle, okay, or you can say one revolution of the circle. Okay. So that should be equal to circumference upon speed. Okay. So that's how we are getting the formula, that it is 2 pi r upon u, and that becomes one of the important aspects of uniform circular motion. कि अगर यूनिफॉर्म सर्कुलर मोशन का स्पीड मुझे पता है और सर्कल का रेडियस मुझे पता है, then I can find out the time period, that is the time taken to complete one cycle of the circular motion. Okay. Just make a note of this also. So this is the next important thing, that whenever we are talking about a uniform circular motion, we are talking about a motion which is periodic, or it keeps repeating itself in cycles in regular intervals of time. Okay. So that period in which it repeats itself, that is called the time period. This term that I mentioned over here, that time period, which we are now denoting with the symbol capital T, that time period. So that time period, how we will calculate it, is the time taken to complete one full circle or one cycle of revolution. Okay, so that is nothing but one circumference divided by speed. So the distance traveled in one circumference or in one cycle is nothing but 2 pi. Just make a note of this. Yes, another way of saying it, therefore, that speed is 2 pi r upon time period. तो यहाँ पे अगर मुझे speed नहीं पता, but मुझे time period पता है और radius पता है, then I can calculate the speed from that. Okay, so people, hope you have finished writing this down and this point is clear over here. Now let's do a numerical example of how we make use of this formula. The time period is 2 pi r upon u, or you can also say u is 2 pi r upon time period. Okay. Either way. So let's see an example. Okay. So suppose we are having a circular path like this example of a certain radius. So a particle moves in a circle of radius r equal to 10 meters at a speed u equal to 2 pi meters per second, or that is basically 2 into 3.14 meters per second. Now, if the particle starts from the point E, where the point E is over here, at t equal to 0. First of all, find the time period, capital T, of its uniform circular motion. Secondly, if this point here is B, okay, yes, correct. This point here is C, then find the time at which it reaches B, and similarly the time at which it reaches C. And third, find the average velocity for the motion from A to B and A to C. Just try this out. Uniform circular motion. I had written earlier, UCM means uniform circular motion. Yes, Aparna, your answer is correct. Bhagyashri, your answer is also correct. Yeah, Harsh, just work out the first two questions, then I'll scroll down. No, Dhyaneshwar, this is not correct, your answer. Forming I've written up about what is UCM. Tejas correct, Shashwat correct. Yes, Harsh, that is correct. E to B or average velocity, it is correct. Dhruv Ahuja, correct. Vyom, Shashwat, your answers are correct. Tejas, your answer to second part is correct. Aparna, just check your calculation for the displacement for the average velocity. Rest of your answers are correct. Okay, so let me start explaining this question. So first of all, you can see that the time period, the circular motion, uniform circular motion, it is given by the simple formula circumference upon speed. Okay, so that here becomes 2 pi into 10 meters divided by the speed which was 2 pi in meters per second. So we're getting the time period in seconds to be 10 seconds. This is the simple answer for the first part. Now for the second part, you can see that A to B, okay, the particle covers half the circular part. So distance traveled is half of the circumference now. So obviously time will be how much? It will be half of the time period. Okay, or that is the same thing as pi r divided by E. So the time taken from A to B, कितना हो जाएगा? सिर्फ 5 seconds. Similarly, you can see that A to C, the particle covers 3/4 the circular part. That means the distance is equal to 3/4 of 2 pi. Therefore, time should be 3/4 of time period. Or that is the same thing as the distance traveled divided by the speed. So the time taken from A to C becomes 7.5 seconds because capital T was 10 seconds. So very simple. This is like just application of unitary method kind of thing. Okay. So that you can see from the diagram. From this diagram, you can clearly understand this. What is happening. Okay, Yuvraj, hope it is clear now. Okay, so just make a note of the second part, then we'll go back to the third part of the question. Yeah, Bhamik, I'm showing. Okay, so hope the first and second part are now clear to all of you. Now third part, remember average velocity का definition क्या होता है? It is not speed. Okay, it is displacement upon time. Third part, when you're doing, make sure you're clear about the application of proper definition. Remember that average velocity is defined as displacement upon time. That is the ratio of displacement covered divided by the time interval. So please make sure that you calculate the displacement properly. Displacement and distance are not the same thing, remember. So let's come to the third part. In the third part, you can see that from A to B, what is the displacement from A to B? Is this one. This is the displacement, 10 meters. Right? It's one diameter. So it is equal to twice of the radius for 20 meters, one diameter. Okay. And the time taken that we've seen earlier, that was half the time period. It was 5 seconds. Both of these things we have seen. The time taken from A to B was 5 seconds, right? And the radius, the circular track was 10 meters. So the average speed, average velocity from A to B will be the displacement from A to B divided by the time interval. So that average velocity will become 20 by 5 or 4 meters per second. And you can see this is a different value to speed. Note that speed u was how much? 2 pi meters per second. So that is approximately 2 into 3.14 or 6.28 meters per second. So you can understand here what is happening. The average velocity is less than the speed. Why? Because the motion is not along a straight line. Why this is occurring? This is because the displacement is less than the distance traveled, because this is not a straight line motion. It is not a motion along a straight line. So naturally, as expected, the average speed, the average velocity for any particular part of the motion is considerably less than the speed, the uniform speed. Okay. Now, similarly, you also calculate for A to C. Calculate for A to C. What is the average velocity? And I have calculated for this is A to B. So apply exactly the same method. And make sure you note down this point here also, because it's important to be able to interpret yes, that average velocity is something else and speed is something else, even though it is going with uniform speed, because the path is not a straight path. So, yeah, Janeshwar, you can rejoin. No problem. Yeah, Dhruv, your answer is correct. Yes. Adinath, correct. Tejas, correct. U is 2 pi meters per second, beta speed. Question में दिया हुआ था 2 pi meters per second. It's the same thing. Vyom, U is speed. That speed was given to us in the question as 2 pi meters per second. Got it now? Yes, that is correct. Yuvraj, displacement is correct. Now just divide it by the time and you'll get the answer. Okay, so in the same diagram, you can see that for the motion from A to C, what is happening is our displacement is this one. This is our displacement. From A to C. And it reaches C, also that gets seen at a time of 7.5 seconds. Whereas it had reached B at a time of 5 seconds. So now you can use the property of right angle triangle, and from that hypotenuse you can get. So this is a 90-degree angle, this is 10, this is 10. So this will become how much? 10. So the displacement from A to C is like that, and the time is 7.5 seconds. So for A to C, you can see the displacement is R root 2, 10 root 2 meters, or approximately 14.14 meters. And the time 7.5 seconds. Okay. So the average velocity from A to C will become displacement from A to C divided by the time interval. So 10 root 2 divided by 7.5. Again, meters divided by seconds. Get the answer in meters per second. So this average velocity will come out to be, you can write it as 4 by 3 root 2. Okay. And then you can make it 4 by 3 into 1.4. Approximately. So you get approximately the answer like this. Okay, so this is the average velocity from A to C. So go through the diagram and once more. Yeah, Dhaneshwar, I've got your message. Don't keep repeating the same message again. Have some patience. So A to C, you can see that displacement is how much? It is the hypotenuse of that triangle. So you see that triangle. This is the point A. This is the center of the circular path. This is the point C. Now you have to find out how much this hypotenuse is. So this radius is 10 meters. So this hypotenuse is R root 2 or 10 root 2 meters. Okay. So the displacement from A to C, that's why here we have written the displacement from A to C is this. So now divide that displacement of magnitude 10 root 2 meters with the time taken of 7.5 seconds. So हमने पहले निकाला था. In the second part of the question, we had found out the time taken from A to C. That was 3/4 of the time period. So time period was 10 seconds. So that time was 3/4 of 10 or 7.5 seconds. So now divide that displacement by the time and you get the average velocity. Okay, so done with this. Hope all of you are clear about this now. Let's look at another example. Now this time, the information given to us will be about time. And we will have to calculate the information about speed from this. Okay. This time, what is given to us is that a particle moves from A to B in a time of 5 seconds. So the particle moves in uniform circular motion of radius 20 meters from A to B in 5 seconds. So first of all, find its speed u, and second, find the time at which t at which the particle is at the point C. Okay. Now, additionally, this point C is shown to us. It is over here. Now, this point C is such that if we join C with the center of the circular motion, then this angle is in fact 45 degrees. Work this question out. Yes, Bhattacharya is correct. Panna, unfortunately, not correct. Bhagyashree correct. Vyom and Bhagyashree, your answers are correct. Group not correct. Yes, Bhagyashree, your second answer is also correct. No, the time for reaching B is given as 5 seconds. So here what you can understand is that E to B, the time is 5 seconds. And the particle covers half the circle. So therefore, time period will be how much? 10 seconds, double of this. And therefore, speed will be how much? 2 pi r upon time period. So 2 pi into 20 meters divided by 10 seconds. So 4 pi meters per second, or approximately 12.57. You can leave the answer as 4 pi meters per second. That's fine. So that is the speed. Adinath correct. Shashwat correct. Okay. Now you can see that as far as the time for reaching C is concerned, from B to C, the particle covers 1/8 of the circular path. So how do we understand it is 1/8 of the circular path? Because see that this is 90 degrees. So suppose this point was our B. and suppose this point is D. Now you can see that D to D is 1/4 of the circle. Why? Because 90 degrees is 1/4 of 360 degrees. Okay. Now similarly, यहाँ पे, where is the point C? The point C is here, which is further cutting this in half. No? This is 45. That is 45. So therefore, you will see that D to C is half of D to D. So it is half of 1/4 of the circle. So it's 1/8. That is B to C. Remember here it was at t equal to 0. Here it was at t equal to 5 seconds. Now here we have to find the time. So you can see that the time interval from B to C will be 1/8 of one time period. So that will become 1/8 of 10 seconds or 1.25 seconds. Therefore, it reaches, the particle reaches C at a total time of how much? 5 plus 1.25. The time when it is at B, that is 5 seconds, plus the time taken to go from B to C, so that is 1.25. 6.25 seconds. So just make a note of this part carefully and tell me if anything is not clear. I'll explain again. No, we didn't assume t is 10 beta. It was given to us in the question that E to B, the time taken is 5 seconds. And E to B is, you can see it's covering one diameter, or the path traveled is half of the circumference. So that's how we know that the time period of the circular motion is how much? It is 10 seconds. The time period of the uniform circular motion is 10 seconds. We got that because it was given to us in the question that A to B kitna time le raha tha? 5 seconds. Okay, beta, Yuvraj, is clear now, na? Okay. Now, the final aspect of circular motion, uniform circular motion, you understand, is something called angular displacement and angular velocity. So next thing you'll understand is the concept of angular displacement, delta theta, and angular velocity, which we denote with a symbol, with a Greek symbol omega. It looks like a W, but that symbol is called omega. In uniform circular motion. But before that, we have to go back to mathematics and understand what is the definition of angle. Geometrically, what is the definition of angle? Can anybody tell me what is the definition of angle? How do we define angle in mathematics or geometry? Anybody knows? This is like general knowledge, guys. You should know this. But matlab, how? Achha, let me explain. Okay, so no, that beta Adinath and Dhyaneshwar, that angle, that definition you are all giving, Atharva, Adinath, Dhyaneshwar, that is like one of the properties of an angle or what an angle describes. Okay, but what is the definition of angle itself? No, it's a very simple definition. I'll explain. Wait a minute. Okay, I'll explain. So angle is actually defined like this, that angle is defined in this way, that if an arc subtends a certain angle, just a moment, guys. If an arc subtends a certain angle, then there's a relationship between the angle and the arc length, and that is actually the definition of the angle. So, अगर मैंने ऐसा एक arc draw किया, जो कि theta subtend कर रहा है, this radius is r, and this arc length from here to here, this arc length is s. Then the definition of the angle is that the angle is defined as the ratio of the arc length subtended divided by the radius. This is the angle in radians. Okay. And radians is nothing but the SI unit. This is the definition of angle. And that is why we say that angle is a dimensionless quantity. It is dimensionless because it is distance divided by distance. Okay. So here S is the arc length and R is the radius. That is how we mathematically or geometrically define them. Okay, so just make a note of this first. Now you will realize when I give you a couple of examples that this is something very obvious actually. It's not something very surprising. It's actually very obvious. Yeah, Dhaneshwar, just note this down. This is what the definition of angle is. And the SI unit of angle is radians. So for example, you'll see how obvious this is with the next two examples. So for example, for a quarter circular arc. Okay. If we draw a quarter circular arc, you know that the angle subtended is how much? 90 degrees. So in radians, it is how much? It's pi by 2. So if I'm now just talking about this full circle is not present. Okay. Just talking about this portion, okay, which is subtending an angle of what we know is 90 degrees. Okay. So if this radius is r, this arc length from here to here, we know is how much? This arc length is pi r by 2, no? It's 1/4 of circumference. Okay. It's 1/4 of the circumference. And that is why the angle subtended, this theta, you can see is arc upon radius. That is pi r by 2 divided by r. So theta is equal to pi by 2 for quarter circular arc. And that pi by 2 is nothing but 90 degrees. Pi by 2 radians is equal to 90 degrees. Because you know that 360 degrees is 2 pi radians. This is the unit of conversion. Or 1 degree is 2 pi by 360 radians. So 90 degrees is nothing but pi by 2 radians. So understood this example, no? So similarly, not only in the case of quarter arc, but for example, if you take a semicircle, similarly, for a semicircle, if you draw a semicircle like this is the total angle subtended. And what about the arc? It is pi r. You can see that theta is how much? S by r. So it is pi radians, or pi r by r. So theta is equal to pi for semicircular arc, or pi is equivalent to 180 degrees. Similarly, for full circle, theta is equal to 2 pi r divided by r. That is nothing but 2 pi, which is the same thing as 360 degrees. So therefore, for any arbitrary arc, in general, what happens? Theta is equal to arc upon radius. So the general definition of theta, an angle theta expressed in radians, is nothing but a simple ratio. Just like in trigonometry, you know that tan theta is the definition of perpendicular upon base for that right angle triangle. Similarly, cos theta is the ratio of base upon hypotenuse. So similarly, the definition of angle itself is also in terms of ratio, but it is a ratio of what? Arc length upon radius. So when you rotate a radius through an angle theta, the arc that it traces, that arc length is such a value that ratio of that arc divided by radius is nothing but the angle measured in radians. Is this definition clear to all of you people? If there's any doubt in this, please let me know. Because again, there's something very important here. Okay. Finish writing. Okay, people, so I'm assuming you finished writing this. Yes. Okay, next thing. Let us understand angular displacement in a circular motion. Okay, now suppose a particle goes in circular motion. It was here at some time t equal to t1. Okay, and then going along the circular path, it reached this point at time t equal to t2. So let's say this point is A and this point is B. So the particle in circular motion moves from A to B in time t1 to t2. Then during that time, the line joining the particle with the center, whatever angle it traces, that is called the angular displacement, delta theta. So delta theta is the angular displacement from t equal to t1 to. So in words, what is that angular displacement? It is the angle through which the radius turns. That's that time interval. What it understood this? So this is the definition of angular displacement. So just note down this definition first, then we'll understand more about it. So SI unit of angular displacement is radians. Delta theta, the standard international unit is radians. Okay, people. So if we define angular displacement in this way, then the next thing is how we will define angular velocity. So angular velocity, which we denote with the symbol omega. This time we'll define it in uniform circular motion. So angular velocity is defined as delta theta by delta t. Rate of change of angular displacement respect to time. This is the definition. The angular velocity is rate of change of angular displacement, which we denote by delta theta with respect to the time in which that's happening, which is delta. So it becomes this. Okay. So omega's SI unit is radians per second. Okay. Now the interesting thing is that since angle is equal to arc upon radius, okay, so therefore for an angular displacement delta theta, the distance covered, let's say delta S will be how much? It will be R delta theta. Now this thing we can understand from a similar diagram like we've drawn earlier. So what is happening is if a particle in a certain amount of time, if a particle is in a certain amount of time going from here to here, okay, then what is the distance it is covering? That's the arc length. Okay. And what is the angular displacement it is covering? Delta theta. So the relationship between this arc length and angle will be that angular displacement is arc length divided by radius. So that means what is the circular distance traveled along the arc? There is nothing but R delta. So that's how we are getting this. So now next thing we'll see is interesting, that therefore since angular velocity is delta theta by delta t, so we can also write angular velocity as 1 upon r into r delta theta by delta t. So just multiply, divide by r, and now you can see r delta theta is nothing but linear distance or distance traveled along the circular path. So it is distance upon time. Okay. Now delta S by delta t is nothing but distance upon time, which in this case is the uniform speed, because we are talking about uniform circular motion. So the relationship between omega and this thing becomes, it is u by r. So this is also something very important. Okay, so this is the relationship between angular velocity omega expressed in radians per second and the speed u expressed in meters per second in a uniform circular motion. Of radius r in meters. This relationship. Okay, so this is extremely important over here. Okay, so I'm seeing it from this point where you understand angular velocity's definition. Okay. And from angular velocity's definition, we can see the relationship between angular velocity and the speed of a circular motion. Yes, I'll explain. Just note this down fully first, then I'll explain it. Okay, finish writing this down, then I'll explain. Yeah, Yuvraj, I'll show that section again once. Right? Okay, so let's look at the whole thing again. Angular displacement. When we come back to angular velocity. Okay, so let's understand the relationship between angular displacement and angular velocity again. So we just saw that definition of angular velocity is delta theta by delta t. So if I multiply both sides with r, I'll get this. But now I know that in a circular path, if a particle moves from here to here, let's say, in a certain amount of time, so from t to t plus delta t, it has covered an angular displacement delta theta. So what is the distance traveled by that particle during that time? That this distance from here to here, जो circular distance है वो कितना होता है? That distance will be nothing but r delta theta, because this is coming from the definition that angle is equal to arc upon radius. This is the definition of angle. Okay, so then I can put this back over here, and I can see that therefore r omega is nothing but the arc length distance traveled divided by time. So this is nothing but distance upon time. So that is nothing but the uniform speed. So r omega is equal to u, or omega is equal to u by r. That is how we get the relationship between the speed and the angular speed. So what was happening? See, this equation was the definition. This is the definition of angular velocity. It is rate of change of angular displacement. Now, ये equation को दोनों side में अगर हम radius से multiply कर देते हैं, so on the right hand side we'll get what? We will get r into delta theta by delta t. Now it's a matter of interpretation. कि r delta theta क्या होता है? It is nothing but the arc length delta s. So in a time delta t, if it's covering an arc length of delta s, then that arc length delta s is how much? It is r delta theta. So back to this definition, I can replace this r delta theta this with what? Delta s. This quantity r delta theta can be replaced here with what? Delta s. And delta s is nothing but the distance traveled by the particle in the time delta t. So this is nothing but the speed, the uniform speed u. Because remember, we are talking about a uniform circular motion. Is it clear now? Is the derivation clear? Okay. So let us understand one very simple example. You have to find the angular displacement very good, thank you, of the seconds hand of a clock, okay, from, let's say, okay, from exactly 1 p.m. to 1 p.m. and 20 seconds. Okay. This is hours, this is minutes, this is seconds. So find the angular displacement of the seconds hand of the clock in this much time. So anybody got the answer? भाग्यश्री आपने आंसर डिग्रीज में दिया है. ओके, your answer is correct, but it's in degrees, so you have to convert it to radians. Your values are correct in degrees, okay, but you convert it in radians. So I have asked for this in radians. So remember the conversion, 180 degrees is equal to pi radians. So use that conversion factor, that 180 degrees is equal to pi radians. Yes, correct, Adina. Correct, Aparna. Okay, so you can see that if this is your clock, okay, now suppose this is your hours hand and this is your minutes hand and your seconds hand. You suppose this one. Okay. So this is when your time will be exactly 1 p.m. This is how this will look. But now, by the time the time is become 1 minute and 20 seconds. So your hour hand will still be pointing at 1, slightly ahead of 1, but negligible. Similarly, your minute hand will point almost at 0. But importantly, your seconds hand would have come somewhere here. So here, it have gone from it would have gone to this. Okay, so you can see that the angular displacement for the seconds hand is going to be this. So this is our 1 p.m. and 20 seconds. This one. तो बस अपने को ये एंगल निकालना है, बस ज्योमेट्रिकली ये एंगल निकालना है. So this angle delta theta will be what? So you can see that for this circle, this is 90. Okay. This is where your 3 is. 4, 5, 6. So this angle here, this is how much? This is 90 by 3 or 30. And this is 90. This one. So our total, this is 90 plus 30 or 120 degrees, which is the same thing as 120 into pi by 180. So 2 pi by 3 radians. This is the angular displacement for this. This is from in 20 seconds. This is the angular displacement in 20 seconds. Is it clear? Okay. Now again, when the time is 45 seconds, it reaches here. This is where it reaches at 45 seconds. Okay. So now you can see that for 45 seconds, this is the angular displacement. Okay, so similarly, you will see delta theta is equal to 90 plus 90 plus 90 or 270. So that is the same thing as 4 pi by 3 radians for time of 45 seconds. You can also think of it like 3/4 of a circle. Sorry, this is not 4 pi by 3. My mistake. It is 3/4 of a circle. So 3 pi by 2. Okay. So now you can see that it's in uniform circular motion. So angular speed will obviously remain constant. So since it's a uniform circular motion, therefore the angular speed, which is u by r, is uniform. So not only in uniform circular motion speed is uniform, but also angular speed is uniform. Okay. And that angular speed we can calculate now this way. Whichever of the two we can use. Okay, so that angular speed is delta theta by delta t. So we can see that it was 2 pi by 3 in 20 seconds. Okay. Or that is the same thing as it was 3 pi by 2 in 45 seconds. Or that's the same thing as it completes one full cycle in 60 seconds. Okay, because we know that the time period is 60 seconds for the seconds hand. And a full circle is 2 pi radians. Okay, so we can see that the angular speed is pi by 30 radians per second. That is the angular velocity of the seconds hand. So interestingly, there is also another relationship, okay, that we should know here. That omega, the angular velocity, we write as u by r, the speed divided by radius. But it can also be written as 2 pi upon time period. And this you can understand this way because time period was 2 pi r by e. So this thing can also be written in this way. There's another formula for the angular speed. Yes, Dhaneshwar, the recording will be made available, so don't worry. I am recording the lecture, it will be available. Yes, you can rejoin. Okay, so these are some example questions of uniform circular motion. Okay. You will find some more examples in your this thing in your module. Now, I just want to discuss a couple of questions from the module which have been sent to me as doubts. So let me check again. Yeah, so earlier today I received some requests from some of you to solve some of the questions. Okay. But the Parva, more than a derivation, it's like an equivalent formula only. So this omega is u by r is the same thing as 2 pi upon time period. It's just like this because your u by r. Now u you can think as 2 pi r upon time period. That's how that becomes 2 pi upon 10. Okay, so just a couple of questions. The remaining time I want to solve. Okay. So just open your module, the physics 1 module, to the first chapter, kinematics exercise, on page 27 or something. Come to exercise 3. Okay, we will discuss question number 6 and 7. So I might not have time to discuss all the doubts today, but I will discuss few of them at least. Okay. So module physics 1, okay. Kinematics exercise 3. Okay. Question number 6. Come to this. This will be on page 6 is on page 22, I think. Yeah, page 22. Now, this one you notice is a very similar question to that relative acceleration thing that we discussed. The day we were doing relative motion in one dimension. It's exactly like that. So just go through the question, all of you. I'll explain it. It says the stone is released from an elevator going up with a uniform acceleration of e. The acceleration of the stone after it is released is how much? Okay. So what you have to be careful about this type of a question is that acceleration of the stone पूछा है. So किसके respect में acceleration निकालेंगे? Because see what is happening here. The elevator is going up with an acceleration e. Okay. And the stone is released on the elevator, let's say. So it starts falling down the moment it is released. Okay. But now the question that has been asked is you have to find the acceleration of the stone when released, okay, inside the elevator. So we've released it inside the elevator. But notice in the question, nothing is said with respect to whom or relative to whom. So when nothing is said, relative to whom, you have to find the acceleration of the stone, but the question is relative to which frame. Okay. So the thing here is that since nothing is given, we will take the answer to that we'll take is ground frame by default. Okay, so if the question doesn't specify कि किसके frame में निकालना है, then we always take it in ground frame by default. Okay, and not in the elevator's frame. So there is somebody else standing on the ground over here. He's at rest on the ground. Okay, let's say he's the observer E, and there's another guy inside the elevator. So this will be in A's frame, not in B's frame. So in A's frame, what is happening? This is actually coming down with G. So in A's frame, what is happening is the stone is falling with an acceleration of G, whereas the elevator, the floor of the elevator is going up at E. This is what the guy A sees. Okay, so the answer will become G. So in the ground frame, that is the frame of the observer E, the stone will have a downward acceleration of G, and the elevator has an upward acceleration of T. Okay. Whereas if you talk about the observer B, then it's a different matter. For the observer B, what is happening? Okay. So here our answer will be this, okay, because that's what we're looking for. However, in the elevator spring, that is observer B, in his frame what is happening is that he will see the stone coming down with some relative acceleration. So this will be acceleration of the stone with respect to the elevator. So the acceleration of the stone with respect to the elevator will become E plus G downwards. This is in B's frame. Okay. How we know this? Because we know the formula that the acceleration of the stone with respect to the elevator is acceleration of the stone minus acceleration of the elevator. Now acceleration of the stone is minus G because it is downwards, and acceleration of the elevator is plus A because it is upwards. So acceleration of the stone with respect to the elevator becomes, with proper sign, minus G plus A. Okay. So the minus sign is just showing you that it is downwards. Okay. However, the thing is, question में ये नहीं बोला है कि elevator के respect में we have to find. Question में बोला है that you have to just find the acceleration of the stone. So remember one thing, that when nothing is specified in the question, then the default frame that we always take is the ground frame. Okay. So Dhruv, I think you're the one who's asked this question. Hope this is clear. Okay, just give me a second. I'll reshare the screen because I have to restart that program. Giving me some errors. Just give me a second. But Dhruv, if you can just answer to me. Okay. I think you are the one who had posted this question, or at least you are one of the people who had posted this question. So have you understood this point? कि question में reference frame जब नहीं बोला है, कौन सा reference frame में निकालना है? Then which reference frame you have to take by default? You have to take the ground frame. So with respect to ground, what is happening? The stone is falling with an acceleration of G, and the elevator is going with an acceleration of A upwards. Okay. Just give me a minute, guys. I'll restart the whiteboard. Okay. Yes, with respect to elevator होता बेटा, then it would be G plus A. Okay. So just note this down, people. Okay, and then we'll do the 7th question next after this. Yes. Now, 7th question is a question which is just about vertical motion. It's not a relative motion question. So it's a question based on motion under gravity. Okay, Bhaumik, finished? Okay. All right. So 7th question, let me explain the question. So क्या हो रहा है कि we are doing an experiment where from the top of a tower or a building of a certain height, exercise 3 only, from the top of a certain building or a certain height, tower, one object, let's say A, is thrown up at a speed u, and another object B is thrown vertically downward at the same speed u. Okay, and they hit a floor which is at a height h below. So we have to find the relation between VA and VB. So VA is the speed at which A hits the floor, and this is the speed at which B hits the floor. Okay, so let me in fact color code them. Okay. So what will happen here is the stone A will tend to go up first, go up like this, and then return back, and then come and hit the ground with some speed VA. Okay. Whereas the stone B, we take a different color to label it. Okay. So this one B को मैंने सीधे नीचे फेंका है, but with the same speed U. So B will come straight down like this and hit the ground with some speed BB. So I have to find the relation between VA and BB. Okay. So Dhruv, what do you think the answer should be? They are equal or what? No, it's not correct. VA won't be greater than VA. Okay, I'll explain. So how we can find VA? So to find VA, what we can do is, since A was thrown up with the speed of U at t equal to 0. Okay. So what we'll do is, for A, we'll take this as a positive y-axis. Okay. So for A, what will happen? The initial velocity we'll write as plus u with a positive sign, but the acceleration will be what? Minus g, because obviously it's motion under gravity. So the acceleration due to gravity is g downwards always. The g vector is downwards. Okay. So when it hits the ground, whenever it hits the ground below, what will be the displacement? The displacement of this will become what? It will become s like this, and this is the height of the building from which we had thrown. This height was h. So when it hits the ground, the displacement s will be how much? It will be minus h. Why? Because we have taken the positive y-axis upwards. Okay, Dhruv, so this is clear. So what is the relationship? That v square is equal to u square plus 2as. So in this, the final velocity with which it is hitting is, say, va. So va square will be equal to plus u ka whole square plus 2 into the acceleration, which is minus d, into the displacement, which is minus h. So we have va square is equal to u square plus 2. So we have the formula for va. It is square root of u square plus 2. Okay. Now let us compare this with the same process done for b. Now for b, what is happening is that t equal to 0, you are throwing it down with the speed of u. Okay. And it's coming to the same height and hitting the floor at some speed v, and same acceleration due to gravity acting on it. This height is h. So for b, what we can do is we can take the downward direction as a positive y-axis. Why? Because our initial velocity is in the downward direction. So then we'll write u as plus u, but this time we'll write a also as plus g, and we'll write the displacement also as plus h. So we'll get vb square is equal to plus u square plus 2 into plus g into plus h. So you see, it's giving us the same relation, that vb square is equal to u square plus 2gh. So Vb is equal to square root of u square plus 2gh. So you can see from this that Va is equal to Vb is equal to square root of u square plus 2gh. Okay. Now this doesn't seem so obvious in the beginning maybe, but the equations will give you the understanding of this. And one more thing you can understand which will help you accept this answer is that, you know, if you compare the motion of A and B, what is happening is A को जब मैंने यहाँ से प्रोजेक्ट किया ऐसे स्पीड U से, so it first goes up and it comes down. Now on its way down, as it crosses this point, it has the same speed U, and just like at the highest point, its velocity becomes 0. And that's why when it reaches a certain height below, its velocity becomes square root of U squared plus 2. Let's compare this motion with the motion of B. B को मैं directly ऐसा फेंक रहा हूँ, but same height से नीचे जा रहा है ना, so it will have the same velocity. Okay, so that is why you can see that A takes more time. Okay, more time compared to B. But dA is equal to B because A is traveling this extra path going up and coming down. But ये जो part of motion है A का, second part of the motion, वो exactly B के motion के बराबर है. There's no difference at all. Okay, so that is why your B is equal to B. Have you understood better, Dhruv? Okay, so I'm just minimizing this. Alright people, so we'll conclude today's lecture here. I think we have a maths lecture also coming up in a few minutes. So continue working on the exercise 3 and 4 of the kinematics. And next time, depending on how many questions we have to discuss, we will also start with Newton's laws of motion. So you can start reading the next chapter in your module, which is Newton's laws of motion, because we will be discussing that very soon after completing all the doubts and questions. Okay. That's it guys, thank you.